ठीक है. So let me tell you one thing, that this LU decomposition is one matrix decomposition, and which means that you can divide this matrix, or you can basically partition this matrix into two parts, L and U. So here we will see the two methods to do this decomposition, and one of the method is very straightforward, but it is lengthy. Another method is very short, and it is not intuitive to you. Okay, it will not be intuitive to you, which means like it is very easy, short, but you will not be knowing the mathematics behind that method, because it is not required for gate. So let me go about telling both the methods, and let me tell that what is this LU decomposition. So basically, given a matrix, you want to do what? You want to divide this matrix into two parts, such that one of the matrix is lower half, another matrix is upper half. Which means that here, let's suppose it is 3 by 3, then here you will be having, this is basically 1 0 0, this is some non-zero, this is 1 0, some non-zero 1 0 1. So basically you will be dividing this into two parts, and one of the part is just a lower half, which means these values, lower triangle matrix means these values are non-zeros, and above diagonal values are zeros. Okay, and on the diagonal it could be anything, zeros or non-zeros. On the diagonal it could be anything. This is called triangular matrix. You know this? Like I will obviously teach it, but the lower triangular matrix is that you have zeros here, you have non-zeros here, and here it is anything. This matrix is called lower triangular. Okay. But in LU decomposition, I have a special lower triangular where on the diagonal I have one only. I have one, and everything is zero, and these are the non-zeros. And upper triangular matrix is that on the diagonal it could be anything, and like this could be anything. This is 0 0. Then sorry, this is upper triangular, right? So this is some non-zero, this is non-zero, and then this is 0 non-zero non-zero, this is 0, this is 0, this is non-zero. So here here we are dividing a matrix into two parts. One is L, which is a lower triangular matrix, which means that these are non-zeros. On the diagonal it is 1, it is just special. And another one is U, where you have on the above the diagonal it is non-zero, on the diagonal it could be anything. Like unlike this, it is 1, it is not fixed here. Okay, it could be anything. So let me write this L and U. See, this L could be like this. This is L, this is U. So you have 1, you have 0, you have 0. Now, since it is lower triangle, you will be having this as, let me call it L 2 1, second row, first column. And then this will be 1, then this will be 0. Then this is L, third row, first column, L, third row, second column, and then this is 1. This is your L. Okay, this is how your L will look like. Basically, you need to find these three values only. 1 2 3. What are those three values? And similarly, your U will look like this. Here, you will be having U1 1, U1 2, U1 3, and then it is 0. This is U2 2, U2 3. This is 0, and then this is 0, and then this is U3 3. Okay, this is your U. So which means that you need to find these three values here, and I think 1 2 3 4 4 5 6, these 6 values here, if the matrix is of size 3 by 3. Idea is clear that we want to divide this matrix into two parts, L and U. And not always, the division is not always possible. The division is only possible, like I will tell you one condition, when you can reduce this A, if you're starting with the A, into a row echelon form without any row exchange. Okay, let's just see it. Let's just work with some example, and then you will get it. Okay, so let's have this A as a matrix. Then I will do what? I will divide this matrix, or I will just factor this matrix into two parts. That is called LU factorization. So let me factor this matrix into two parts. One is L, another one is U. So how L will look like? Let me write like this. So L will look like this, where on the diagonal you have 1, and this is 0, this is 0. This could be anything that I need to find out. This is 0. This could be anything. This could be anything. I need to find out. Okay. So this value I need to find out. This value I need to find out. This value I need to find out. So this is L. and the u is like you know the u, right? Okay, so let's just do with one of the method. One method is bit tricky and shortcut. So I'm first telling you shortcut and then we will go to the long method. Can anyone guess the long method first? Maybe if I just ask you to guess it from here, maybe you can guess. Let's suppose it is A11, A12, A13, A21, A22, A23, A31, A32, A33. Can you guess it? Maybe you can do one thing. Maybe you can just multiply L and U, and whatever you are having, then you can just compare, and then you can multiply and then compare. Yes. So this is a bit long. I mean, I'm not sure if it is long or not, but another is definitely short. Okay, I'm not sure that is short. I think that is short. Let's just see this. Let's first see the short method. So it says that you make this into echelon form. If you want, I can tell you the mathematics behind this method, but it is not required for GATE. Okay, so I will just ask you to avoid it. If you want, we can discuss the mathematics also. So anyway, this method says that convert that into echelon form. So let's just convert this into echelon form. So what is the operation that you will be applying? You will say that R2 should get replaced by R2 plus 2R1. Right? R2 should get replaced by R2 plus 2R1. Now, every of this statement is important, and you must be applying only and only this kind of elementary operation, which means you cannot have k here. You cannot have k here. Just have normal elementary operations. Okay, in this case. So if you apply this, then you will convert this matrix, which is 1, 4, minus 3 to 0, R2 plus 2R1. So 8 plus 8, it is 16. 5 plus minus 6, it is minus 1, and 3, 4, 7. Okay? And then you got 0 here. Is this okay to everyone? Just understand step by step. Now, see, you multiply 2 R1 and R2 you cannot multiply anyway, because as I told you that you need to keep this coefficient as 1. Now just put this 2 here in this L, okay, and reverse sign of this, just put minus 2 here. So just say that, okay, to make it 0, what you did, to make this entry 0, what you did, you applied this row transformation. So that is why, like, instead of this entry in the corresponding L, you will be having opposite of that sign, which is minus 2. Let me just tell you more. So just now make this 0. Just now make this 3 0. What you need to apply? R3 should be R3 minus 3R1. Okay? Now what will the final matrix? After applying, you will be getting 1, 4, minus 3, 0, 16, minus 1, and R3 minus 3R1, it will be 0. Then 4 minus 12, which is minus 8, 7 plus 9, which is 16. So this will be the final matrix. Now, can you tell me to make this 0, or like what you did? You basically had minus 3 here. Okay? So what you should be writing here? What you should be writing here? 3. Yes. Actually, like, I do not feel comfortable when I do not tell any proof or any method. So I'm not feeling very excited to tell you this. But yeah, like for you, trust me, the mathematics is not required, because it will take entire 3 hours if I explain you. It is very nice. Let me tell you, it is very, very nice mathematics. Like how it is going to be the reverse of this. It is very nice, but it will take the entire 3 hours, and obviously it is not needed. And just let me just tell you, this LU decomposition in past, I think 36 years or 30 years, I do not remember, like from where GATE has started. I think 36. Do anyone knows that GATEOverflow has how many years of papers? I think 36 years or something. 37 years. Okay. So in past 37 years, as far as I know, like I have seen that only 2 times they have asked. Okay, maybe 3 times, I'm not 100% sure, but as far as I remember, only 2 times they have asked, or 2 or maybe 3 times, but as far as I remember, it is only 2 times. So that is why it is not necessary to overwhelm you with so much of information. Okay, so this is 3. Okay, now tell me what you should be applying to make this 0. You can make R3 plus maybe 2R2. ठीक है, R3 plus 2R2. Then what will the matrix that you will be getting? Sorry. So it will be let me just minimize this. Now I got it that why my lectures are taking too much of time. Maybe just adjustment. Okay. So if you just apply this, then what will the final matrix? This is 1, 4 minus 3, 0, 16 minus 1. This is 0. I think R3 plus 2R2. It will be 0. And R3 plus 2R2. This is 16 plus minus 2, which is 14. Is this correct? Yeah. So this should be, can you tell me this number? This should be what? Minus 2. Yes. So this is your L and this is your U. Finally, we get U and this is your L. I mean, you are incrementally building L like this. And when you are converting into the row echelon form, then you automatically get your U. So let me just check the answer if I have the answers. No, something is wrong. 1 minus 2. R2 divided by 2. Why? Okay, this is, okay, this is not, this last is wrong. Sorry. This should be R2 divided by 2. Yeah. Yeah. Sorry. R2 divided by 2. Yes. So this is 0. And then if you do R2 divided by 2, then it will be 16 minus 1, which is 15.5 minus half, which is 15.5. And now it is not minus 2, it is minus 1 by 2. Okay. So L is 100 minus 2, 10, 3 minus 1 by 2, 1. Let's just check it. L is 100 minus 2, 10, 3 minus 1 by 2, 1. This is L, and U is 1, 4 minus 3, 0, 16 minus 1, 0, 0, 15.5. Yeah, that is correct. So that's how you can decompose it. You got the idea that whenever you are having any operation, just write the opposite of that in these three places. That's all. Okay. And then finally, you will automatically be getting U, and this is your A. So I think this is, I mean, comparatively, this is easier way. Okay. And let's just do it in another way, which means let's just find out using this way. So what is our matrices? Let me quickly do it. 1, 4 minus 3. It is 1, 4 minus 3. And then minus 2, 8, 5. Minus 2, 8, 5. This is 3, 4, 7. Equal to, can you tell me this number? This should be U11. Okay. So U11 you can easily calculate. And then this will be this vector will get multiplied with this. This will be U12 plus U. This is U12 only, right? This is just U12. And then this will get multiplied with this. This is U13. Okay. Now this will get multiplied with this. This is L21 into U11. And then this is L21 into U12 plus U22. This is L21 into U13 plus U23. Okay. Here, this is L31 into U11. This is L31 into U12 plus L32 into U22. And here you have the whole thing. I mean, L31 into U13 plus L32 into U23 plus U33. Okay. I think it will be a bit long, but anyway, let's just do it quickly. So now you have, let me erase this. Can you tell me U11? U11 will be straightforward. It is 1. U12 is 4. U13 is minus 3. Now using this U11, okay. 1 second, let me plug in my charger. Yeah. So using this U11, you can find out the L21. How? L21 will be L21 into U11 is -2. So you can say from here only, this is 1, this U11 is 1. So L21 will be -2. Okay. So L21 is -2. And then since this is -2, U12 is 4 into 4 -8. And then U22 will be -8, 8 plus 8, 16, right? U22 will be 16. And then you have L21. Do you have L21? I think, yeah, -2 into U13, which is -3. U23 you need to calculate, which is 6. And then this is 5. So 5 minus 6, it will be -1. U23 is -1. Okay. Let me check if I'm getting answers correctly. So it is 4, 1, 4 minus 3. 1, 4 minus 3. And then U22 and U23. This is 16 and 1. 16 and -1. Yeah, that is correct. So till now, everything is correct. Okay. I think you can do it as a homework. Like these, from these 3 questions, you can find out, right? So this, you need to plug in the value of U11, then you will be getting this. Then you need to plug, I think, almost all the values to get this L32 like that. Okay. So you can do it as a homework. So it is like, it is the last resort that you have. If you just forget that what we need to do, I mean, if we need to have the opposite of sign here or not, or like that, if you just forget, then just do it. Otherwise, I will not recommend you to do it, because you just see that how easy it is, right? You just need to plug in the opposite of that value. That's all. Okay, so you can take your own call which you want to do, but we should be knowing both the methods. Reason being is that we do not know the proof or anything about the shortcut. This is a shortcut method and we do not know the proof of this. So maybe the chances that you might forget it. So in case if you forget it, then you should be at least attempting the question. So you can attempt the question in the long way, in case if you forget the shortcut. Okay. Okay. So that is okay. Now you can do this as an homework. Let me just put this as an homework. So here you need to find the LU decomposition, and I think I have the answers here. Okay. Now let's solve one more question, which is very interesting. So they are saying that find LU decomposition of this matrix when it exists, and for which real numbers A and B does it exist. That's what they are asking. So they have given a matrix. Then they are saying, then first of all, find LU decomposition when it exists, which means do some setting of A and B, some condition on A and B, if at all required. If it is not required, then awesome. If at all required, then do some condition on A and B, find L and U, and also tell the condition that you have applied to find the LU decomposition. You got the question? What I'm saying? See, you need to find the LU decomposition. And on the way, maybe you need to put some condition on A and B, like, okay, A is greater than B, A minus B greater than 0, something like that. Okay. And if you are putting the condition, then just tell those conditions also. Let's just solve this question. So it is 101. This is A, B, B. Okay. So what is the L? L is basically lower triangular matrix. So you will say it is 1, it is 0, it is 0. It is something, it is 1, 0, it is something, it is 1. Okay. You need to find 3 values, which is this, and this. Okay. So let's do step by step. So this is A. Now let me just do step by step. Let me remove this. Can you find the LU decomposition using the shortcut method? Let me just try it. So what we will need to do, we need to convert this to 0 and this to 0. So to convert this to 0, I will having R2 should be replaced by R2 minus AR1. Okay? R2 minus AR1. So you will be having this 1, 0, 1, then 0, R2 minus AR1. So it is A minus A, it is 0, right? This is BA. Okay. Now tell me what I should be writing here. Plus A or minus A? Plus A, right? So I should be writing plus A. Okay. Now let's just make this also 0. So let me make this 0. So I will do one thing. I will say that R3 should be replaced by R3 minus BR1. Yeah, right. So this will be 1 0 1 0 a 0, and then this will be 0 r3 मतलब b minus something which is b, a minus b, so it will be a minus b. Okay. Now what I should be writing here? B. Yes. So I should be writing B. Now only one entry is left. So till now, tell me, do I have to have some condition on A and B? I don't think, like, for any general A and B, it should be working. Okay. I have not put any restriction on A and B. Let's just see if I need to put any restriction on the way. Okay. Maybe I do not need to put any restriction. Let's just see. So now I need to do what? I need to basically make this 0. Can you tell me what should I do to make this 0? R3 should be replaced by R3 minus B by A R2. Yeah, B by A. Actually, whatever is the pivot element, always that pivot element will be in the division. Okay, whatever is the pivot element, that will be in the division, and then this element get multiplied. So B by A. Now tell me, should I be putting any restriction to have B by A? Yes, A should not be 0, right? A should not be 0. So I should be saying that A is not 0. Actually, if A is 0, let's not worry about this. Okay, let's not worry about this for a moment. If A is 0, then I cannot select it as a pivot. Okay, I will be stuck here only. If A is 0, I cannot select it as a pivot, and then I will do what? I need to swap the rows. I need to swap the rows. If A is 0, then I need to swap the rows. Everyone agree? And if A is 0, then can I convert that to a row echelon form without swapping the rows? No, right? So without swapping the rows, I cannot convert, because I will be stuck here. If A is 0, then without swapping these two rows, because I need the non-zero here. And to have the non-zero here, I have to swap these two. Okay. Now, I will say that if A is 0, then I cannot convert that to a row echelon form. That is why A should be non-zero, because I'm choosing this as a pivot. And what does this condition say of LU decomposition that I have written on the front page? That it exists when A is a matrix. Okay, A must be able to reduce to row echelon form U without interchanging row echelon form, and finally the row echelon form is basically, we are calling that to U, without interchanging any rows. Okay, so without interchanging rows, we must be able to convert. Now check here. If A is 0, then can we convert? No. So that's why I need to put A is not equal to 0 as in one condition. Because if A is 0, then I need to swap the rows, and it is not possible to convert. So A is not 0, and then I should be converting. Okay. So if I need to write this, then can you tell me what I should be writing here? This should be B by A, Everyone agree? B by A. So basically L is this, and this will be, let me also write the U. It is 1 0 1 0 A 0. It will be R3 minus B by A. B by A into R2. So yeah, anyway R2 is 0. So it is A minus B. So this is U. Okay, this is A. If you want, you can verify it. I mean, verify in the sense, you can multiply L and U, and you can check whether you are getting the same answer or not. So this is L and this is U. Let me check. These are same, right? A minus B, these are same. So how to verify it? You know it. So to verify it, you need to multiply L and U, and finally you will be getting the original matrix. So always verify. If there is any doubt, then verify. Okay. So this is all about the LU decomposition. I mean, in the next class, and not in today's class, I will tell you one or two lines more, that how to solve the system of linear equations using LU decomposition. But anyway, for now, I will just tell you that how to decompose a matrix into L and U. So there are two methods. I hope you got both of them. And I know that this shortcut method is actually very, very easy. That is why I'm telling you the shortcut method without even proving this shortcut method. But I hope that is okay. I mean, they have very less significant weightage of this LU decomposition, and we do not need to know the proof of this. Okay. So that is all about the LU decomposition. If there is any doubt, then let me know. Otherwise, we will meet in the next lecture. Thank you, everyone. We will meet in the next lecture. Bye bye. Take care.